Okay, so we're gonna get started with the tour. Thank you everyone for being here today. Happy Monday. Thank you those returning and our new attendees for joining us for our Microgrid Mondays event series put on by the Town of Cohasset's Alternative Energy Committee and co-sponsored by the Northeast Commerce Association and Metropolitan Area Planning Council. If you missed our previous events or want to rewatch them, we record all of these webinars and plan on uploading them to the Town of Cohasset YouTube page soon. You'll receive an email from me once they're uploaded with details on how to access them. As people who have attended every session so far know, every week is just a different perspective with new information, so it's worth watching the previous webinars. And just a reminder that we are currently expanding our schedule to the end of March, including both of the rain dates. So next Monday, March 15th, we're hoping to have a tour with NG at the Lawnwood Medical Facility in Boston. On March 22nd, we plan to see some more nanogrids and backup generators. And March 29th, we're trying to reschedule our tour with the Siemens Living Lab in Princeton, New Jersey. So make sure you're registered by going to the Cohasset Alternative Energy Committee landing page, clicking the registration link, and filling in your information. Now today's tour with Schneider Electric is going to be full of information, visuals, and hopefully questions. You're welcome to put any questions into the Q&A box at the bottom of your screen during the tour. Don't panic if it doesn't get answered right away or even at all, because at the end of the tour you are going to be able to unmute yourselves and ask live questions. Now we've also got industry experts from Schneider Electric and a representative from the Metropolitan Area Planning Council on the call today who are all excited to talk with you. And since today's tour has a lot of pieces to it, we're probably going to run over 1 o'clock. So if that's the case and you have to hop off before getting to ask your questions, you can always email them to me or ask to be put in touch with any of the people on the call today. My email is bbennett@cohassetma.org. I'll also add that in the chat towards the end for you. So allow me to introduce Dave and Bill, our Schneider Electric tour guides for today before I hand it over to them. Dave is Director of Strategic Accounts for Schneider Electric USA, and today in this new energy landscape, Dave brings 25 years of industry experience delivering a comprehensive range of solutions that help decentralize, digitize, and decarbonize energy. In his current role as part of the Power and Grid team at Schneider Electric, David leads a team focused on energy transition solutions that drive CapEx and OpEx savings, sustainability and resilient solutions, and other key business goals for their clients. Bill is part of the Schneider Electric North American Microgrid Competency Center, where he currently serves as the team's project development and engineering manager for North America East. He is focused on microgrids and distributed energy resource projects spanning from the customer side of the meter to the utility control center. He also assists in general business development and marketing activities, product research and development, and mentors the Competency Center's Microgrid Solutions Architects, a team that he previously managed. Prior to his current role with Schneider Electric, Bill worked as a microgrid solutions architect and manager and a business development and marketing specialist. Bill holds a master's degrees in renewable energy engineering, building science and efficiency, and general experimental psychology, as well as a bachelor's degree in psychology from Appalachian State University. And he's available to connect on LinkedIn. So Bill and Dave, thank you for being here and working so hard to put this tour together. If you're ready, I'll let you take it away.
Yeah, thanks a lot, Brianna. Big thank you to you and your team for helping us get this virtual Microgrid tour set up as well. Like you said, I'm joined by my good friend and my colleague Bill Flegger from our Microgrid Competency Center. Also, big thank you to the MAPC team and also to Nika, for helping us get this sponsored. So like Brianna said, we've got a ton of information to share with you. We've got a couple of different videos. We're going to go a little deep on some of the technology. We've also got a video from one of our customers. So without further ado, I think we just need to jump in. We're already about 8 minutes into the hour here. So here's the brief agenda. We can move the agenda around a little bit, but we'd like to be able to stick to it so that we can see the full value of our microgrid up here up here in Andover for Schneider Electric. But so we just wanted to introduce you a little bit about who Schneider Electric is, but also most importantly, who our Microgrid Competency Center is. So that's our MGCC. That's a team internally within Schneider Electric. And that's the team that we've built to be able to help our customers and our partners to be able to drive, microgrids into their facilities. But most importantly, where we want to start is what we call baseline. So, helping our customers define exactly what a microgrid is, just because the terminology microgrid is widely used and there's a wide and varied definitions. So we like to start there, but then take you on a tour of our microgrid at our R&D center up in Andover, and then talk about some technology, primarily what we call our ECC, our Energy Control Center, and our EMA, our Ecostruxure Microgrid Advisor. And then Bill's going to do a little bit of a deep dive on other individual offers and opportunities, and then we'll land on a customer video, which we think is pretty close to what we believe to be some of the other community-based microgrid opportunities, and then we'll leave some place for Q&A. So, Bill, you want to just do a real quick, yeah. So let's just go through a little bit who Schneider Electric is first. Again, I'm the director of one of our strategic accounts teams, what we call Power and Grid. And Schneider Electric is a global corporation, about 25 billion euros, about 32 billion US, but we're geographically spread pretty much throughout the entire globe. We do business in, I think it's 110 different countries. But the most important thing that we want you folks to understand today is we've recently moved our U.S. corporate, our North American headquarters to Boston, and this is part of an internal strategy that we want to be able to better align and be more of a local company than such a global company. So we have an internal strategy to be able to deliver more community-based microgrid opportunities, because we clearly see the need and the alignment to work with the community. So that's part of the initial effort here. So go ahead and move this forward, Bill. But like we said, most importantly, what we want you to recognize is that there's a team set up within Schneider Electric called the Microgrid Competency Center. So we're part of what we call Power and Grid. So we work on smart grid opportunities directly with the utilities, but microgrid opportunities directly with the customers that are behind the meter types of solutions, because there's similar different types of offers and opportunities. It just depends upon how you're trying to drive a solution for that specific customer. So again, what we want you to understand is that there's a team specifically set up to be able to address your existing concerns, and we're going to go through the different types of offers and how we support teams and so on. But Bill's a big part of this team to help us drive those individual solutions and needs for our customers out there in the market. But you've got a team that is here local, but is based throughout the entire North American region, led by Mr. Mark Fiesel, who's our president of our smart grid teams here. Go ahead, Bill. And so let's land on what is a microgrid. I'm going to give you my definition here, and I'm going to let Bill pretty much weigh in with some feedback here. So this to us is a very, very important slide, because again, it really helps ground the discussion from the customer's perspective. So, the easiest way to understand this is that the customer, whether it's an industrial customer or a community, you've traditionally purchased your power from an older way of buying power, but now today you have the ability to self-generate your own power. So recognizing that a microgrid is a couple of different things. Number one, it's an integrated energy system. So what it does is it takes individual disparate systems that you may have today, or you may want to be able to add into the community today. So existing solar, wind, generation, energy storage, it takes all those existing DERs, which today are disparate. So they sit in their own silos and they don't work well together. And so microgrid takes those disparate systems and integrates them so that you've got one system that is operating as one system, and is then trying to be able to resolve whatever the issue is for the customer, whether it's be energy cost reduction, better resiliency, achieving whatever their sustainability goals are. So you have one integrated system that is controlled as a single entity, but then most importantly has the to operate in parallel with the grid, or intentionally as in an island mode. So when the grid fails or when the utility fails, you have the ability to now generate your own power needs at that specific location using the individual distributed energy resources, but now operating as a system. So that's where we wanted to start this discussion. Bill, you want to add anything? And then let me open up just real quickly for just one or two questions there.
Yeah, sure, Dave. I think you've hit the nail on the head there. You know, the definition you see on the screen is Schneider's definition, and it also very closely aligns with the IEEE's definition. I think that as companies try to do, and municipalities and individuals try to be greening their energy mix, we've seen an opportunity of decentralized power. First kind of coming in a wave of PV, and now entities are trying to seek ways of using that PV without the grid. So a lot of people don't necessarily know that when the utility grid goes away, you can't use your PV system anymore. So you have a stranded asset there, right? And microgrids are a technology that allows you to take advantage of that and make it a resilient asset. So I think that's one of the drivers that we've touched on. The other thing I'd like to point out is this term, you know, we like to say, if you've seen one microgrid, you've only seen one microgrid, right? Because they're all very unique. Everybody has their own flavor, their own mix of distributed energy resources at their site. And that term in itself is something that I'd like to just touch on real quickly. Distributed energy resource, or you may hear me say, refer to that as a DER or DER. Really, there's three main types of those. And I think people focus or quickly understand the first type, which are generation assets, things that produce electricity for you. So traditional diesel backup generator is an example of one, or that new PV array that you had installed on your parking deck could be another. But increasingly, energy storage is a second category that we see in microgrids more and more commonly, probably in the form of battery energy storage. And then the third type, people often forget, and it's a disappointment to me because they can be just as powerful as a generation or storage asset to your microgrid. And in fact, they can save you investment costs in those other assets. And this third category are flexible and controllable loads, something that we can turn on or off or dial up or down, such as your HVAC system. And in that manner, it can work the same as discharging an energy storage device. And so these three categories really all come together in a microgrid in a very unique fashion. And we'll see that at our Andover R&D facility microgrid tour in a bit.
Great. So let's just take one real quick question. There's a question, Bill, in how does Schneider's definition of microgrid differ from IEEE?
Oh, that's a good question. So there's really not too many differences. There's one minor difference, and it's really down to the specificity of the language. So at Schneider, we would suggest that a microgrid does not necessarily have to island or have to be capable of islanding to be a microgrid. And the IEEE definition, just the way that it's written, would suggest that it does need to island.
Good. Okay, so why don't I move on here?
All righty. So in the vein of just getting a little bit more flavor around what these microgrid systems are, basically there's a microgrid out there for anybody. Whether you're at the small residential scale, traditional, commercial office building type of a thing, maybe a warehouse or a manufacturing site, all the way up to a campus style microgrid, or even a subsection of a utility wide area can be a microgrid. So there are technologies at all ranges of the scale for microgrids. There are also three main types of microgrids. And this is back to the definitional difference between IEEE and Schneider. There are microgrids that are always grid tied. There are microgrids that are capable of islanding, and by that we mean separating themselves physically from the utility and operating by themselves. And then there are microgrids that are always an island, and this could be the case for, say, a remote community, or perhaps just a region where a utility isn't capable of serving. Beyond that, there are some major components of microgrids. Now, not every microgrid will have all of these components. As I said, sometimes when you've seen one microgrid, you've only seen one microgrid. But these are the main categories of components that we see in microgrids today. Loads being one that we touched on earlier. There are all types of different loads, though, that can be experienced within a microgrid. So anything that's drawing power is an electrical load, and a microgrid has to be ready to manage that load. And so different loads with different characteristics mean different things, different actions need to be taken within your microgrid so that they are appropriately handled. Particularly, microgrids can be economized, and the barrier to entry into microgrids can be lowered if you can prioritize loads within your facility and identify those that are critical to maintain during a utility outage and those that you could live without. These systems also involve electrical distribution equipment, so things like that load center you have at your home or in your apartment, all the way up to much larger stuff that we put in commercial buildings like switchboard and switchgear, even at the medium voltage level beyond a 480 volt, maybe a 13 4 kV or something of that nature. They also involve distributed energy resources, and we've talked quite a bit about those already, so I'm going to move past that. And then one of the most interesting aspects of microgrids is that they can have a number of different types of controls and software that help to not just run the microgrid, but optimize them. And we'll see examples of that in our microgrid tour. Dave touched on this a little bit when he started. There are several advantages of investing in microgrids and drivers behind implementing them. Cost, resilience, and sustainability are the three main ones that Schneider likes to focus on. And I would point out cost, it's always nice to lower costs, but what can be more important or equally as important to municipalities and people who have an operating budget that they need to work with is having long-term predictable costs. And this can be a benefit that microgrids also deliver. So with that being said, I'd like to play a video about our Boston One campus microgrid. Now it's called the Andover Research and Development Center. We had a naming convention switch last year. So you're going to hear Ed, the site manager for Boston One, now Andover R&D, describe why Schneider implemented their microgrid at this site. And you're going to hear these three drivers in his story.
I truly appreciate New England. I was born in New Hampshire. I love the four seasons. I love the change of seasons, the variety. The energy management landscape is always changing as well, and at Schneider Electric, we work hard to be leaders in that space. My name is Ed Muskis. I'm the site general manager for Boston One campus here in Andover, Mass. Boston One campus houses 4 of our 5 business units for R&D development, so it's extremely important that this building is operational 24/7. So we signed up here to implement a microgrid as a service project, partnering with Duke Energy Renewables and REC Solar. A microgrid is a system that allows us to automate and control distributed energy and determine where we draw our energy from. For example, solar generators, the grid power, and in the future, battery as well. Another innovation was microgrid as a service, the end-to-end solution where, as a customer, I don't worry about financing it, I don't worry about maintaining it. I just gain the benefit of reduced cost and uptime of my facility. For us as a customer, the third benefit was to maintain this building as a living laboratory for the further development of that technology. For example, the Energy Control Center, which allows for the automation and control of the overall system. And Ecostruxure Microgrid Advisor is software and allows us to view the energy generation and consumption of the solar microgrid. I really think Schneider Electric is leading the digital transformation of energy management and automation. We have to do more with less, and the solar and microgrid technology provide customers the opportunity to have a choice of where they get their energy and at the same time to reduce their costs.
So that was just a quick overview of the Andover R&D microgrid. I did want to put up this graphic, and we're going to revisit this graphic a couple times during the presentation. There's a lot going on in this, but this is a representative architecture of the microgrid that we have deployed in Andover. As Ed mentioned, it is a living laboratory for Schneider, and so some parts and pieces get swapped in and out from time to time. And so for one example of that, you'll hear in a moment from our CTO, Lance Haynes, and he'll discuss about the addition of a battery system to our microgrid. And he'll demonstrate how that battery impacts the operations of the microgrid. But actually now today, we actually have removed that battery and are testing a UPS system in there as a new endeavor for the microgrid. And so you'll just see different things, but the picture you're seeing on the screen is the total capability of our microgrid at Andover. There are kind of three levels I want to draw your attention to in this graphic. The bottom level has our distributed energy resources listed on it. And so you'll see here that we have a utility connection that we manage. We have a natural gas engine, and this is a backup generator. We have a rooftop PV array, and if you caught during the rundown of the agenda that Dave gave, there were actual pictures of that, or if you were waiting while we were beginning, there was a photo of some of those photovoltaic arrays as well. We also have two separate parking lot canopy PV arrays. One canopy is facing sort of optimally south, and another canopy is offset so that we could see how our energy usage and later production could be increased when we still had some load in the building. And it also happened to just work out that way because that's how our parking lot was laid out. We also have EV chargers connected to the microgrid. And so when we talked about flexible loads, this is something that can be dialed up or down or turned off. And we also have the HVAC system, or actually our building management system, connected to the microgrid so that we can play around with optimizing between those two systems. And then, as I mentioned, we have a battery system. Today, right now, it's being tested out as a UPS. Beyond that, there are two other levels, and Lance is going to talk about these three levels of things too, and he'll give you a little bit more detailed information about this and how Schneider thinks about this. But at its most basic, we have a power management system, Ecostruxure microgrid operations, and an energy management platform, Ecostruxure microgrid advisor. Now, what Lance will be talking to you next about is our Ecostruxure microgrid operations power management platform. And it is in and of itself contained into an integrated product that really productizes and makes microgrids easy and rapidly deployable for the end user. This device is called the Energy Control Center. And so you'll see Lance actually physically standing near this piece of equipment and pointing out different aspects of it. So Lance's video is about 15 to 20 minutes long. And I'm going to just switch to that now and let Lance tell you a little bit more about our microgrid at Boston 1.
Welcome to the Microgrid Lab at the Andover R&D Center of Schneider Electric. We're really glad you're able to visit us today virtually, and we do hope to see you again live at some point in the future when people do that again. So when people come to the Microgrid Lab here in Andover, what we love to share with them is our Ecostruxure microgrid solutions. And figure to help us guide through this conversation. So a little bit about how it works. We have these three different layers in the Ecostruxure stack that are doing completely different things at different time frames. At the bottom level, we have our connected products. Up a level, we have our edge control. And then finally at the top, we have our apps, analytics, and services. So there's many offers in this overall suite that we'll be talking about in more detail. so much to get a microgrid to work, the enemy is really complexity. And what we're working very hard here at Schneider Electric to do is to alleviate the complexity with the various offers in the Ecostruxure microgrid solutions suite. And by alleviating that complexity, we can overcome the barriers to microgrids being more widespread. We're now going to dive into a little more detail about, and in fact, we're going to use the microgrid that we have here at this facility as the example that we go through, like a case study. So as you notice in the Ecostruxure architecture, it all starts on the bottom with the connected products. And there are a lot of different examples of connected products in a microgrid. I'll start with a few that are right here inside the Energy Control Center. So this piece of white electrical equipment next to me is an Energy Control Center, or ECC for short. And it has several different sizes of smart breakers in it, ranging from 150 amps, 250 amps, 600 amps, and 1200 amps. And so that's an example of a connected product that's inside the ECC. But there are many other examples. For instance, uninterruptible power supplies elsewhere in the facility, PV inverters up on the roof, or a lithium-ion battery energy storage system, or a genset just next to the building. All these things are great examples of connected products. And the key thing that makes them connected products is not only do we run the big wires over to the connected product to collect up the power and to allow the high amps to flow through, but we also run the little wires over. And that's where the bits and the bytes are able to flow back and forth so that information can be communicated and control signals can flow. And the white arrows up and down the stack here in the Ecostruxure diagram, that's exactly what they're trying to indicate, is the flow of information up and down the stack. So connected products tend to do a function very fast, sort of in the millisecond time frame, and they tend to do it quite autonomously. So an example of that, again, using the breaker would be if there's a short circuit on the load downstream of the breaker is going to open in tens of milliseconds, and it doesn't need anybody's permission to do that. It's a breaker. That's what circuit breakers do, right? But turns out these smart breakers have little embedded power meters built into them. So they know not only the current, but they know the voltage, and therefore the power, the reactive power, the frequency, the power factor, you name it. All the great information you could pull from a power meter, we can pull from these smart breakers and have that information flow up to other layers of the stack. So the next layer up, edge control, is really all about resiliency. So the offer here that Schneider has, Ecostruxure microgrid operation, can work together with the connected products in order to provide resiliency for a site. And it can do that quite quickly, kind of on a second-by-second basis. So for example, if the edge controller found out from one of the breakers that the utility voltage had gone away due to an outage, it could send a command to open the main breaker in the ECC to isolate from that grid that's down. And then it would send a command to start up an anchor resource, like a generator or a lithium-ion battery energy storage system. And then it would sequence in the load breakers quite quickly. And within seconds, we've got everything back on that the local resources are able to power. Now, that is how the two bottom layers, edge control and connected products, work together to provide resiliency. But here in the US, luckily, the grid is up over 99% of the time. And so that begs the question of what's the optimal thing to do while the grid is up? And that's where Ecostruxure Microgrid Advisor comes in up at the apps and analytics level. It is looking to optimize the economics of the system to maximize the return on investment from the resources that have been put in at the site. So that's kind of a minute-by-minute type of question. And that's why you see the minute time frame up here on this top level of the Ecostruxure architecture as applied to microgrids. So a good example of that might be if you have a lithium-ion battery energy storage system, on a minute-by-minute basis, we need to decide, should we be charging the battery or discharging the battery? We're just waiting patiently because it's not the right time to do either one. So connected products very quickly do some autonomous function. Edge control in a microgrid is primarily to provide resiliency. And at the apps, analytics, and services level, Ecostruxure Microgrid Advisor provides economic optimization. So now we're going to dig into the case study of this site, the Andover R&D Center of Schneider Electric. And we'll start with kind of a zoomed out look of the building from an electrical point of view. So this is a simplified one-line diagram of our site before we put in the microgrid. And so you can see we have 2 MVA service coming in from the local utility and a lot of 480 volt loads. One very large load, which is a chiller. And that really ties into our peak load for the site. On a very hot summer day, we'll get up to about 1.5 megawatt peak. And that's why we go ahead and give that HVAC load its own special symbol in our simplified one line here. And then in terms of original backup power at the site, we had a very conventional arrangement here with a 400 kilowatt natural gas generator feeding as the alternate source for an automatic transfer switch, the ATS you see here. And either utility power or generator power feeds through the ATS to an uninterruptible power supply, which then feeds the data center and critical loads in the facility. And that way, even if the utility goes down and it takes a few seconds to bring up the generator, the data center and critical loads never even see a blink thanks to the UPS. Okay? Now, one thing you may notice here is 400 kilowatt generator, and we only had 200 kilowatts of data center and critical load. And with this setup, there's no way to use that extra capacity of the generator. That extra 200 kilowatts of capacity it has no path to any of these other loads. So that means all these other loads up on the main distribution board, they all go dark during an outage in our initial setup. So that was one of the main things we were looking to do better at as we implemented a microgrid with some solar resource here at the Andover R&D Center. So let's take a look at what we did. So we put in an energy control center, the piece of equipment I'm standing next to, and we did some analysis of the loads that were going dark during an outage that were the most painful. And we found a couple of very important loads, one of which has a 200-person conference center. So we could have people travel here from all over the world to come to some event in our conference center. And if the power went down and we had them in the dark, we'd just have to send them back to their hotels. And that's not ideal, especially if you traveled from far away. And so that sector of the building is one of the things that we moved over into the ECC to become part of the microgrid. And some other key loads, particularly associated with resiliency plans for shelter in place for a potential winter storm scenario. So we moved these loads into the ECC, and we brought over that otherwise stranded capacity of the generator. So that extra 200 kilowatts that the generator has to give is available to power these additional loads. Furthermore, when we added solar to the site, we connected it into the ECC, and we're in the process of adding a battery to the site, and we'll talk through how that works as well, but that also is connected to the ECC. So when an outage happens, as I'll show in a demo here in a second, the ECC main breaker opens, and the loads in the ECC are served by this combination of the generator, solar if the sun is shining, battery if there's state of charge left in the battery. Okay, so we're going to dive into a little demo here and show how the edge control and the connected products work together to provide resiliency. One last reminder before we do that is don't forget about the 200 kilowatts of critical load that's downstream of the UPS, but it's upstream of the ECC. So when we zoom into the ECC, you won't actually see that load on the ECC, but the generator still feels it. It's still part of what the generator has to address during an outage. So here we go. zooming into the ECC. Okay. We're going to start with this initial condition. And I need to explain one key thing here. Notice the buttons that say simulated outage, simulated PV, simulated load. The issue here is this ECC that I'm standing next to is actually the twin of the other ECC in the main electrical room of this building. So we have two ECCs that are identical functionally. However, the other one has the real utility power, the real solar, the real loads connected to it. And this one is the one that we're able to use for demos, because in the demo, as I open breakers, we'd be leaving hundreds of employees in the dark if we did it with the real ECC. So we established this infrastructure to be able to give this demo without being overly disruptive here at the site. And we're going to keep the simulation quite simple. We'll just start and stop outages. And we can have the solar in one of three simplified positions: sunny, cloudy, nighttime. And the load can be not only moderate, but we'll step it up to heavy at some points. So in this initial condition, you can see our utility is here. It's 480 volts. And it's cloudy day, so our 350 kilowatt array is putting out 190 kilowatts at this particular moment. And that 190 kilowatts coming from the solar array is actually more than the 170 kilowatts of load attached to the ECC. So 20 kilowatts is actually flowing backwards out the main breaker of the ECC and into other parts of the building. So you see that indicated by the negative 20 kilowatts flowing through the main breaker of the ECC. So we're going to go ahead and start a simulated outage here in just a second. And you're going to be able to hear the breakers opening and closing, I think, pretty clearly. Let's go ahead and see what happens. So I'll start the outage now. So you see the utility voltage went to 0. The generator's fired up to 480. 1, 2, 3, breakers click in. That's the generator breaker closing after we gave the generator a few seconds to warm up and stabilize. And then we sequence in the high priority and low priority loads. And so now you see, here we are islanding and everything is back on despite the utility that's down. And notice that the PV is able to work together with the generator to power these loads. In fact, at this particular point in the demonstration, it's roughly a 50-50 ratio between the PV solar and the generator. Now that's fine and dandy if the sun is shining, but if it's nighttime, now our 400 kilowatt generator is working quite hard. It's all the way up at 370 kilowatts. And notice that our load is still just moderate. So let's take a listen and see what happens if the load were to step up to heavy. Bet you heard that. So that is the lower priority load breaker opening, and that allows the rest of the system to continue to be powered. So the high priority load stays on, that data center that you don't see attached to the ECC, but that data center is still being powered. And so that 200 kilowatts of data center and 180 kilowatts here on the high priority load is why the generator is at 380, but it can't take more than that. And you may have even noticed that the generator for just an instant went above 400 kilowatts, and then the controller opened the low priority breaker. So we'll go ahead and see what happens if the sun were to come out. So as the solar power ramps up, notice that little clicking noise, and the system is smart enough to realize now that we're getting help from the sun, we can go ahead and close in the low priority load. Now, eventually, the utility is going to come back on. So let's go ahead and simulate that and witness how this particular system transitions back. So we'll stop our outage. Notice the utility at 480 volts. So we turn the generator off, open the generator breaker first, and then close the utility breaker in. And here we are back connected to the utility. So this is kind of the end of chapter 1 of the story. And somebody almost always asks me at this point, well, how's this system going to work as soon as you guys finish installing the battery? Well, let me go ahead and show you that now. All right, so I've added a battery to the system, and much of the story will be the same. So we'll go ahead and get started. Let's have an outage. Generator comes on, give it a couple seconds, close in the various breakers, and now we've got everything re-energized except the utility, which is at 0 volts, that we've separated from. And again, this is a great situation when the sun is shining, but if it's nighttime, now the generator's really working hard at 370 kilowatts. So now let's take a listen again and see what happens if the load goes heavy. Notice the silence, right? The breaker has not opened. The extra power is coming from the battery, but notice the state of charge of the battery is falling. And when it gets below 5%, the battery shuts down to protect itself, and the load breaker has to be opened so that we can get back to the situation we were in before. Because without any help able to come from the battery, the generator has to do all the work just like before, and you see the same reaction just as you'd expect. When the sun comes out, we can start charging that battery back up. And at some point, we even have enough power to go ahead and reconnect that lower priority load. And eventually, the outage will end. And very similar to before, we'll transition back to utility power.
All right. So hopefully you guys got a little bit behind the scenes look at how the electrical infrastructure works with our on-site microgrid controller at Boston 1, or as we now call it, Andover R&D. The next thing we were going to show you was a video on Ecostruxure Microgrid Advisor. But that video is about 7 minutes, 8 minutes long. And instead of that, I'm going to pull up an alternative slide deck and just walk you through some of those things.
Yeah, Bill, if I could just add just a real quick comment to that. So before you leave this slide, so recognize what Lance just showed us was really the integration of the multiple DERs like Bill has at the bottom, as well as, think of it as the hardware side of the microgrid, the Ecostruxure microgrid operations, which is our microgrid controller, and the ECC, the Energy Control Center. What Bill's going to do next is just do a real quick overview on what the software services deliver to the microgrid and the importance of that. And so while Bill's pulling that up, and go ahead and pull it up now, Bill. Also, just one other point that we want to stress that, again, I'm not sure if we're going to have time to go through this at the end, but this Microgrid Competency Center, this team is here to assist our customers, to assist our partners. We really want to make an effort to be able to really partner with the communities in Massachusetts, because this is our hometown now. And so recognize that's what that team does, is they help the customer define what the proper energy mix is. What do you have today for existing distributed energy resources? What do you want to add for new distributed energy resources? And then you can help them go through the process of determining what are the critical loads, what are the priority loads, everything that Lance just went through. So visually looking at that slide deck, those 3 different levels, what we're going to talk about now is the top level, our Ecostruxure Microgrid Advisor. Go ahead, Bill.
Yeah, thanks, Dave. And I believe one of the participants has asked what a UPS is. Lance spoke to that a little bit, but that stands for uninterruptible power supply. And it's typically a very, very fast reacting battery backup system for very sensitive electrical loads. These are typically a shorter duration battery to get the system to not experience any outage whatsoever upon loss of utility power. It reacts typically around 8 milliseconds, and that allows for those loads to be supported while the generator is turning on. So hopefully that answers that participant's question. But as Dave was mentioning, the next thing we would like to talk to you about is our optimization, our economic optimization engine for our microgrid, which is Ecostruxure Microgrid Advisor. As we all know, microgrids are a great backstop for loss of utility power, but fortunately, most of the time in the United States, our grid is reliable enough, and so microgrids will function the majority of their life as grid connected. But it's nice to have a way to gain a better return on investment for that microgrid through an optimization platform like Ecostruxure Microgrid Advisor. And so this is the exact same system that we have at Boston, at our Andover campus, except for these slides are a little bit more generic. I did want to point out the screen here on the left. These are actual screenshots of the platform itself. When you log in, we call this the energy flower, and it is representing your site in the center with any connected asset as a petal of the flower around the outside. And so for Andover, that would be our grid connection, the battery or UPS system that's connected there now, our EV charging stations, a gas generator, multiple PV arrays, as well as our HVAC system or our building management system. The other flexible sheddable loads are also monitored on this platform as well. The interesting part of this platform is that it is using a whole lot of information from your site, both what's currently happening on your site, as well as historical information about your site. And so it learns how your site uses energy over time. There is some artificial intelligence in this platform doing that. And then it takes that localized information and pairs it with information it pulls down from the cloud. And so that includes information like weather forecasts, which help inform the platform, how much energy am I going to get out of my solar array? Will I have overproduction from that solar array that I can store into my battery? Is there severe weather imminent that's going to hit my site? And do I need to maybe change from an economic optimization strategy to a resilient strategy before that storm gets here so that we are ready for an islanding event? But beyond that, it also understands two other key things. It understands how you pay for your energy from your utility. So that includes things like, do you have seasonal rate variations? Or do you have time of use variations where you might pay a different amount at different hours during the day? Do you have demand charges at your site, which is basically a charge that is levied on the amount of power that you maximally require from the utility? And is there a limit that we want to target your demand to be below so that we don't incur additional charges? It understands all of these aspects. And then the last aspect, when applicable, is it will understand if there are ancillary services that you can participate in to gain additional revenue streams for your microgrid. And so demand response is a very common one, whereby a utility will say, hey, during these periods of time, if you're able to reduce your load, we will pay you for the amount of kilowatts that you reduce your load during that time span. And so the energy management platform, Ecostruxure Microgrid Advisor, understands all of these aspects all at once. It crunches it through an algorithm, and it decides when it's best for you to buy, sell, store, or consume energy from the grid, as well as your local generation storage systems. And it's going to relay this schedule down to the microgrid controller that Lance was having click breakers on and off to execute the schedule of dispatch on when you're going to use your on-site assets. And so in this way, the microgrid produces an ROI for itself that is optimized. This is exactly what we do at Boston One today, using our on-site assets that are allowed to operate in continuous parallel with the utility. And depending on permitting and your area, that will vary. For instance, at Boston, One, we do not operate our gas generator in continuous parallel with the utility because of permitting. But in other jurisdictions, that might be something we could leverage differently. So I'm going to skip a few slides. We saw this one is a little bit zoomed in on the just the way the software looks when you log into it. There's also different metrics and KPIs that are available to the user on the right-hand side. And so you can see things like, where is your demand charge limit set? How much energy have I used from which assets? What kind of weather is coming my way, et cetera, et cetera. You also can compare your emissions against your utilities, so you can see how much greener your site is being compared to if you were just purchasing your power from your local utility. I'm going to skip a few of these in the interest of time to get to the really interesting one. And this is the true strength of this platform, in that it allows you to optimize across multiple distributed energy resources and multiple different use cases for those distributed resources. Things like, can I change my strategy around my time of use tariff, my demand charges, using my own energy that I produce locally first before I use imported utility power, et cetera, et cetera. And so this slide is really showing all of that magic happen on one particular site. Now, this doesn't happen to be our Andover site. This is a customer site. But what you can see happening here is that this site has a time of use tariff where they have low cost of energy, middle cost of energy, and high cost of energy. In addition, this site has to pay demand charges, and they have set a threshold of 800 kilowatts. And so the system knows that if the load ever exceeds 800 kilowatts, this customer will be given additional charges. And those charges can represent up to 50 or more % of a particular utility bill. And they may also have extending consequences, as this site does, for the rest of the year. So what you see happening here is the platform managing a couple of assets that are connected to it, in this case, a solar system and a battery system, in order to optimize around the time of use tariff and the demand charge simultaneously. So here what you see is the battery being charged when grid power is very inexpensive. Then as people enter the building around 8, 9 o'clock, the load starts to increase because now the HVAC system has kicked on. The occupant sensors have realized people are there and want to be comfortable in the building. And on this day, it was a little cloudy. So the solar system had not produced a lot of energy yet. The system recognized that and said, okay, I need to discharge the battery to maintain below my demand charge threshold. And that's exactly what you see here with this squiggly line. And you see the difference in the predicted site demand above the 800 and where it held it to below the 800 demand charge limit. Now, after the solar came back up and the HVAC system had gotten the building comfortable, the load of the building starts to drop off. And you might be puzzled because this line represents the battery charging in not the cheapest time period, but the platform had already looked ahead and knew that we were about to enter a more expensive time period, and having that additional capacity in the battery available to discharge at an expensive time period was more valuable than the savings of purchasing that energy later in the day when it was least expensive. And so it charged it at not the cheapest time to get more savings in cost avoidance during the most expensive time. And so that's the real beauty of this platform. And with that, I'm going to switch back over to our regularly scheduled event. So now you've kind of seen the whole picture of the Boston Andover microgrid. We've talked about both our economic optimization platform, Ecostruxure Microgrid Advisor, and you've seen the integrated product operating in real time in the Energy Control Center, which houses our microgrid controller, Ecostruxure Microgrid Operations. And you saw how that utilized the connected assets, our distributed energy resources on site. So before we move on, I did want to touch on a couple of other things beyond what you saw in the video. We talked about kind of the top level already, but we also, as Dave had briefly mentioned earlier, offer microgrid feasibility studies and analyses. This is often a really great idea to de-risk your project or create the right scope of project for you before you spend a whole lot of money, right? Before you make a large investment, make some assurances that that's the right thing to do for yourself with a relatively small investment. And a lot of companies like Schneider Electric will credit the project if it moves forward with the cost of the feasibility study. So it's virtually at no risk to end users. We also specialize in the engineering and power system designs that go into the microgrid system design beyond a feasibility analysis. So this is the real engineering work and engineering studies that must be carried out anytime you touch an electrical system and interconnect assets to a utility electrical system. And then Dave, I'm going to let you talk a little bit about energy as a service, and then we'll listen to one of our energy as a service customers.
Yeah, thanks, Bill. I think I've got the alpha structure and green structure slide just below this one, Bill. Is that right?
We can find out.
One more. Keep going. One more. So Bill talked about that, and then so lastly, energy as a service. I'm not sure if any of the communities have already started to look at energy as a service as a procurement method, but it is absolutely a viable alternative to a traditional CapEx, investment of a microgrid. Schneider Electric was named by Navigant, I think in 2019, again in 2020 as the leader in energy as a service. Go ahead and move forward, Bill. And I'm not going to spend a whole lot of time on here, but it talks about those three drivers that we said again. And go ahead, Bill, just one more. And recognize that energy as a service is a procurement model. It is a procurement model that is being widely used in the traditional market. It's not uncommon to see solar to be procured through what we call a PPA or a power purchase agreement. Energy as a service is essentially the same thing, where you've got some asset owner that wants to own that asset and then will then monetize the cost of that asset. In this case, the entire microgrid, including the feasibility study, as well as the ongoing operations and maintenance costs of the microgrid over a certain period of time. That's how we secured our microgrid. One more slide, Bill. And then, and so this slide, and we're going to share these slides with you, talk about the difference between a traditional CapEx or an energy as a service. So just recognize that Schneider Electric is heavily involved in the energy as a service opportunity. So Bill, you want to go back up now to the slide for Montgomery County. And so we just want to leave the discussion with this slide. This is one of our existing customers. This is Montgomery County down in Maryland, probably one of the most widely publicized energy as a service microgrids. Go ahead, Bill.
Montgomery County, located in Maryland, is a community that's just on the outside of Washington, D.C. We're over 1 million people, and we have from urban to very rural type environments. My name is Michael Yombrock, and I am the Capital Energy Project Manager. Because we've seen a lot of weather-induced incidences recently that put about 250,000 people without power, we started looking at developing microgrid systems. From the county executive on down, we are very intent on keeping pertinent and important functions that service the community up and operating in the event of a power grid outage. We identified 2 of our major facilities. Public Safety Headquarters houses the fire, the police, Department of Transportation, and Homeland Security. And the other is our correctional facility. If a grid goes down, we're able to provide electrical power from the facility by both the standby generators, the CHP, and the solar. We financed the project using energy as a service. The county pays no money up front. Duke Renewable Energy came in and financed the project, and Schneider Electric assisted us with the development, all the way from conceptual design to permitting to implementation to commissioning and validating the operations of the system. Their Ecostruxure system is one of the prime reasons we selected Schneider. It's state-of-the-art technologies, being able to bring these disparate generation technologies together and operating in sync. Montgomery County will continue to grow. We want to make sure that the community is safe and secure. We're very excited about being one of the first in the country to do a microgrid and be able to provide continual services to the communities.
Great. So, Brianna, we're right at the hour. So I just wanted to just take a brief pause and hopefully maybe start to answer any questions or any comments from anyone.
Yeah, and Dave, maybe I'll jump in with a question I saw on the Q&A first, asking if our EV charging stations were standard or fast chargers or a combination. Currently, they are the standard chargers. And that's just because they are a little bit older Schneider Electric EV chargers. And so we did not have a fast charger at the time when those were installed.
Thanks, Bill.
So I just gave everyone in the audience the ability to speak. So if anyone wants to ask a question and unmute yourself, I know there are a couple of Q&A questions that didn't get answered, so feel free to just ask them out loud. And we have people here who are ready to have a discussion on it. And there is by no means like a time limit. We don't have to cut off. I put some information in the chat in case anyone did have to head off at 1, but we're welcome to stick around as long as you're available.
Yeah, and my apologies if I missed or overlooked anyone's question from earlier. My questions have actually timed out and are frozen, so I did the ones I could see.
Thanks, Bill.
Hey guys, this is another great tour. And I have one question in the chat and one question I wanted to add, but and I think I've been providing a lot of the questions in there. But I just wanted.
Don't be shy. If you have questions, happy to entertain anything.
Yeah. I wanted to know. So that advisor seems amazing, but obviously rates, but policies and the incentives and things like carbon tax that might be on the horizon, they can all impact the cost optimization. And they're happening at every level, from municipal up to federal. Does Schneider have like a small army of people that are sort of keeping track of all that to really optimize the conditions for each microgrid in its local area?
I can take that first, Bill. I'm not sure if you froze. So yes. So again, I mean, part of our process is we typically go through a real quick go no go with the customer, understand what are their immediate needs and concerns for the microgrid. And then we typically draft a concept with a budget, along with some level of potential cost savings, sustainability goals. So that's part of the solution that we provide to the customer. You're absolutely right, though. The ancillary services market, being able to introduce this type of asset into the market is ever changing. So to answer your question, 2 ways. Yes, we have a team. Actually, they're located down in Phoenix. We have a team of about 190 employees. That's what they do. That's what this team does, is they stay abreast of different types of changes that are happening in the marketplace. Now they offer that as a service. It may be a little difficult for a traditional community to apply to that type of a service. It's geared more towards our larger global clients that have facilities throughout the globe. But yes, we can do that. So I guess to answer your question, 2 things is one is we think you have an immediate need for microgrids here in Massachusetts. Our team can support that. We can put a fairly high level concept of what the project will cost, as well as what it will generate in potential ancillary or other financial use case savings. But recognize we have Ecostruxure Microgrid Advisor being built into every microgrid, and we've got I think more microgrids than anybody actually executed in the ground. We've got over 350 of them, and so that's part of the living offer that we offer. So if there is a certain use case or a tariff or some ancillary service that's just coming on board, we want to be able to recognize that and get that into the system to be able to utilize it, figure out how we can demonstrate further further cost savings to the client. Long answer to your real simple question, I think.
The other question I had that is
yeah, and Dave, can you hear me?
Yeah, I can, Bill.
Okay. My Q&A and chat and video functions have frozen, so I can't see anything, but I'm happy to answer any questions that we may get.
Okay, so why don't you let me? Yeah, why don't you let me relay to Bill? I think there's another question coming in. Go ahead, Lanier.
Yeah, and then the other question was, of the 350 microgrids that Schneider has deployed, how many are multi-user microgrids?
How many are what? I'm sorry.
Multi-user microgrids. For example, a town where you may be, powering the police station and then a nearby, housing authority or something like that.
Yeah. So good question. I don't think we have any microgrids where you got multiple different entities, different ownership entities involved. I know that we're working on quite a few. We're actually working on quite a few right here in Massachusetts for the upcoming DOE FOA, the Connected Communities. But yes, you're right. All of our microgrids to date, or I shouldn't say all, because there could be a couple out there that we're working on right now, but most of the microgrids to date are what I would consider single entity. So that Montgomery County, that's two separate microgrids at two separate locations within the county, but they're both county facilities. So it's not like there's a private entity that's also in the mix. So we're not saying we can't do it. It's just there's a whole different challenge there, as in ownership structure and the value of that microgrid. So, but in Connecticut, we've got 3 or 4 microgrids that are in the ground that are similar to the Montgomery County, where you got multiple different facilities within that county ownership, or actually within that town or city ownership. So you got city fire, you've got city police. You may also have a healthcare facility that's somehow organized, but not any direct, microgrids where you got multiple different entities. That's still fairly new to the whole marketplace. It's not a challenge for Schneider. It's more of a challenge on how do you procure it, and how do you, how is that asset owned, and where is the value of that asset lie with the individual ownership. So great question. I don't think has been fully addressed by the market yet.
And Alana, did you have a question before I saw?
Yeah, I put it in the Q&A just now, but I was just wondering, have you worked with any municipalities to date in Massachusetts developing their microgrids?
Well, so let me answer it the easy way. An official microgrid, no. Again, we've got 3 or 4 that are in the process, but we've got multiple different community-based microgrids. Like I said, I think we got 3 or 4 that are actually in the ground. They've been in the ground. Be happy to share case studies on those as well down in Connecticut. But when you break up the microgrid, when you go back to that slide deck that Bill had, the 3 different levels of the slide deck, if you go back to the original definition of a microgrid, an islandable microgrid, no, I can't say we do in Massachusetts. However, we've been in Massachusetts for years. Believe it or not, about 40% of homeowners across the globe have Schneider Electric products. So we get various levels of product and services and relays and panel boards and medium voltage. So all of the components that go into a microgrid we've got, they just haven't been tied together in an islandable microgrid in Massachusetts yet that we can say that we've done. One last point is we also work directly with partners. We've got various other partners that absolutely have microgrids in the ground. Be happy to share some of those, but they wouldn't have been developed by Schneider, but they're still using Schneider Electric products and services. But they're, it's fully developed by some of the third-party partner. Make sense?
Makes sense. Thank you.
I also just want to add on to that question too, that the town of Cohasset, this isn't specific for Schneider Electric, but for our microgrid framework, we've kind of decided that going a route with multiple developers help too. So it's not like one developer needs to have the solution for across the board the entire town's microgrid. Dave, I don't know what the Connecticut communities kind of look like, but with Cohasset, we've sort of employed this idea where we have 3 separate developers working on different aspects of the microgrid, and we're building it out in different parts of the town. And we're hoping that at the end, collectively, it's going to fill the entire community load. But we're not placing the burden on just one developer. Have you worked with other developers and kind of partnered on projects like that?
Sure. Again, a great question. Recognize Schneider Electric is a manufacturer of products and services. At the end of the day, that's what we do. We're not really a developer. We came into the market to help drive the marketplace, and so our microgrid team was actually put into the market to be able to get into the marketplace, go after various segments, so community, federal, commercial, industrial, and to target specific projects across North America and drive them from a development perspective. However, we're also the largest company that no one's ever heard of, even though, like I said, we touch 40% of all energy that's consumed across the globe. So absolutely, our objective now, where we are in this whole phase, is to partner with other entities, other developers. We work with multiple different EPCs throughout North America. We work with quite a few different consulting engineering companies here. And our objective now is to be able to assist in the development of the project, not to be driving it from day one. That's really not what we do best. What we do best is we want to be a technology provider in the marketplace and help the market standardize, on how they get these projects implemented. So our goal of our team is to be able to continue to help the industry make microgrids more repeatable, scalable, and not to be out there driving projects. So we can help you drive them, but it's a good chance that we're probably going to recommend some other developers as well.
Yeah, and Dave, if I might just add, I would say the vast majority of the projects we have done are very similar to the approach Cohasset is taking, where multiple developers are involved, and we're just one voice at the table. The one thing that I would stress is incredibly important when you take that approach is to work with somebody who's knowledgeable about how to put an energy master plan around those individual project activities, so that at the end of the day, you do get the system ultimately that you want to have in place. I've seen a lot of folks take that approach without really putting a master planning around it. And then there are technical aspects that get overlooked, or there are efficiencies that could have been leveraged in a project that are missed. And so you ended up spending a little bit more, or you end up having technology that's not compatible. And so just working with an expert who can help you make the right decisions as you do a multi-phased project with different developers can make a lot of sense too.
Yeah, there's a real quick question from Brian Folds. Brianna, Brian says, have you worked with hospitals to implement solutions? Absolutely. So again, what we told you originally was Schneider Electric internally, we decided to make to build an initiative. That's how Brianna and I think, first got involved. So we're trying to build an initiative to assist the communities here in Massachusetts. So we have a dedicated team that's working on building out what that strategy would be. Looking at healthcare, we're in the middle of, or we're just at the beginning of that campaign where we built a similar campaign for healthcare on the West Coast because of the challenges that healthcare had because of the wildfire. So that's part of how Schneider Electric goes to market, is we see a need, we recognize that need, and it was healthcare, West Coast. Now we see a need for municipalities, or not now. We also see an additional need for municipalities for microgrids because of the challenge that we have with the storm Sandys and everything else, and the storm that you saw that Montgomery County had. So we're actually developing a program now, to target and to assist the marketplace essentially, and that's really how we reach out to Brianna. So.
Yeah, and are there any other questions before we wrap up today? Don't want to cut anyone off. I think this has been a great discussion and a wonderful presentation. I think it was very thoughtfully put together. Thank you so much for joining us today and taking the time. And even it going over one, I'm really glad that we didn't have to cut it off or anything. And I'm glad that we could knowledge share today. I hope you enjoyed being here with us. I did throw my information down in the chat for any attendees that do want to connect afterwards with myself or Dave or Bill or Brooks from MAPC as well. So please, if you do have further questions, don't hesitate to reach out, and I'll see you next week.
Yeah, one last point again, Brianna, thank you to the team and also to Nika and MAPC as well. One last plug here is our Andover facility is open for tours. We have 5,000 people, I think, come through that tour annually. We've got a room of about 200 people, or a room that is capable of holding 200 people. We're working with Brianna and her town, as well as some other towns, to do a more detailed, on-site tour to give you a little bit higher flavor and be able to have some more time to be able to address any specific questions. So I'll share that with Brianna as we start to develop this and share it with Brianna so that she can share it with everyone else on the calls. Thanks again.
Thank you.
Yeah, thanks, Dave. Thanks, Bill. And I'd love to get a tour of that facility sometime. I got a tour of the project that you guys worked on Star Island several years ago.
Oh,
back
great,
in my
yeah.
former professional life, working with island communities on microgrid systems. But yeah, would love to see that back when tours are possible again. So thanks all.
Great. Thanks again.
Thank you, everyone. Have a great evening.